Okay, so in this video we are going to talk about the section 4.7 from the book, which is the variation of parameter. This is another method to solve a second order non-homogeneous equation. Okay, so last time we talked about the method of undetermined coefficient. Okay, so like if the right hand side or the non-homogeneous function, that is gt, is of the form of e to the ax or sine bx or the trig function or the polynomial function, then that method was helpful, right? That method was easy. But that method of undetermined coefficient will be very hard to do if the function on the right hand side, that means the function g on the right side, is on the different form. Okay, so this new method is the method of variation of parameters, can work for the wider range of the functions, but it is not perfect, so it will not be able to do all the problems though. Okay, so what is the main disadvantage of this variation of parameter is it needs the complementary solution first. To find out the particular solution, we need to find out the complementary solution first, and sometimes it is hard to integrate. We will see when do we need to integrate and why it is hard to integrate. Okay, we will see about that. We'll talk about that later. Okay, so what is the steps to do the variation of parameters? So suppose there is a system of two ordinary differential equations. Consider a system x prime equals to ptxt plus gt. See here, gt is not 0. Okay, gt is the non-homogeneous term, where p is a matrix p11, p12, p21, p22, because we are considering a system of two equations here, and gt is g1, g2. There is a theorem. Let's talk about the theorem there. Assume that the entries of the matrix pt, meaning all these functions, and the entries of gt, meaning these two functions, are continuous on an open interval I, and let x1 and x2 are fundamental solution of the homogeneous term without gt. Okay, this is the homogeneous term. Suppose x1 and x2 are this fundamental solution, and then all these p11, p12, p21, p22, g1 and g2 are continuous in an open interval I, then the particular solution of the non-homogeneous form, that is equation 1, can be obtained by this: x sub pt equals to xt, there is times the integral of x inverse t, that means the inverse of x, times the gt. But what is x? Where xt is the matrix component of the solution x1 and x2, and then general solution, the general solution is xpt equals to c1 x1 plus c2 x2, that is from the homogeneous equation, and then plus xpt, that is the particular solution. By the way, in the 4.6, in the method of undetermined coefficient, that particular solution we need to denote by yp. Okay, I think I denoted by just y, but that's not right. So you should denote by y sub p, just to denote that p is the particular solution. Okay, all right. So let us do an example on solving the system of non-homogeneous equation. But this system basically is the system of first order equations, right? But if it is a system of second order equation, you can always change to a system of first order equation and then solve it like this. Okay, so how do I do this? So solve the non-homogeneous system. X1 prime equals to this: x1 minus 4x2 plus 10 cosine t, and then x2 prime is 2x1 minus 5x2 plus 2 over e squared, where the initial condition is x2 0 equals to 4. So initial value is 4, here initial value is 10. So how do I do this? Let's do that. Solution. Let me write down the solution. So first of all, what we do is basically we find out the complementary solution. Okay, how do I find out the complementary solution? Complementary solution is the solution of the homogeneous form, right? So to find the complementary solution, we solve the homogeneous system, right? So what is this homogeneous system? Homogeneous system is x1 prime equals to x1 minus 4x2, and then x2 prime equals to 2x1 minus 5x2, right? What do we do next? We find out the matrix, right? We write in the matrix form, A matrix form, right? And find the eigenvalue of the matrix. So here x equals to ax. So basically x prime equals to ax, right? So where x prime is x1 prime, x2 prime, x is x1, x2, a is, so a is 1, negative 4, 2, negative 5. You guys remember how do I find out the eigenvalue of this matrix? So what we do, you find out 1 minus lambda and then negative 5 minus lambda and find the characteristic equation. What is the characteristic equation? Lambda square minus trace is negative 4 lambda, and then plus the determinant will be negative 4 and then plus 3, right? So negative 4 lambda plus 3. So you'll get, let me write down that. Characteristic equation will be lambda square minus 4 lambda and then plus 3 equals to 0. So what will be the eigenvalues then? Eigenvalues are, you solve this, right? Lambda equals to basically negative 1 and negative 3. That's the eigenvalues, right? So now we find out the eigenvectors, right? How do I find out the eigenvector? Do you remember that? You do A times V. A times V equals to lambda times V, right? What is A? Is 1, negative 4, 2, negative 5, and then V we write V1, V2, that is the eigenvector, equals to lambda is negative 1 times V1, V2. So I'm taking lambda equals to negative 1 here, and if I multiply these two matrices and then solve, we get the eigenvector V equals to say V1, V2 equals to I will get 2, 1. So 2, 1. So similarly for a lambda equals to negative 3, you will get the eigenvector 1, 1. Okay. So what are the fundamental solutions? Then fundamental solutions are e to the lambda t, right? Lambda is negative 1, so negative t, and the v, the eigenvector, and then another is e to the lambda 2t, that is negative 3t, and then v. That's what you get, right? So now to find out the particular solution, this is the formula to find out the particular solution, right? So we need xt. What is xt? Xt is the component of x1 and x2, right? And then we find out the inverse of that to put here, and then you multiply with gt and integrate. So what is xt here then? Xt is this vector. So e to the negative t times 2, 2e to the negative t, and then e to the negative t. That's what you get, right? And x2 is e to the negative 3t, e to the negative 3t. That's what the x2 is, okay? Now what is the determinant of x? So the determinant of x is basically you find out the determinant. 2e to the negative t times e to the negative 3t will be 2e to the negative 4t, right? 2e to the negative 4t, and then minus e to the negative 4t. So basically what you get is e to the negative 4t. That's what you get, the determinant. So what is the inverse then? So to find out the inverse of the matrix, you do inverse of x is basically 1 over the determinant, right? And then what you do is you switch those two numbers, and then you multiply this by the negative sign, right? So what you get is e to the negative 3t, and then e to the negative t, and then you multiply these two numbers by negative sign, negative e, negative t, and then negative e, negative 3t. That is the inverse of the matrix, right? So if you simplify this, basically what you do is you distribute these to each of them, right? What you get is e to the negative 3t over e to the negative 4t, right? And you move that to the top, you will get e to the t. So the first number will be e to the t. Similarly, the second number will be negative e to the t. The third number will be negative e to the 3t, and then the fourth number will be 2 e to the 3t. That's what you get. That is the inverse of the matrix. Now we use that formula in the theorem. What is xp? The particular solution is basically we use x of t times the integral of x inverse of t times g of t, right? And then dt. That's what you do. So let us plug in those in the matrix form. What do you get there? Let us first write down xt in the matrix form. Let me write down slightly smaller. So you will get e to the 2e to the negative t, right? So let me write down 2e to the negative t, and then e to the negative 3t, and then e to the negative t, and then e to the negative 3t. That is x. Similarly, write down x inverse t and gt. Okay, so whenever you plug in the value of x and x inverse, this is on this formula, you get this is the matrix x, this is the matrix f inverse, and this is the matrix g. G1 is the non-homogeneous term on the first equation, and G2 is the non-homogeneous term in the second equation. By the way, there was a error when I wrote the question. It is e to the t, okay? It is not e to the 2, it is e to the t. So that's what I wrote, 2 over e to the t, okay? Next, what we do is you multiply these two matrices. How do you multiply? E to the t times 10 cosine t is 10 e to the t cosine t, and then negative e to the t times 2 over e to the t. So e to the t will cancel out, and then you will get negative 2, right? Similarly, 10 e to the negative 3t, negative 10 e to the 3t cosine t, and plus you multiply this with that, you will get 4 and then e to the twice t. Now you integrate each of them, but before you integrate, did you see that there is like e to the t cosine t? We have the formula for that. Do you remember this formula? Let me write on the formula. Okay, now you want to find out the integral of this, but there are two rows, right? We find out the integral of separate row for the first row and then the second row, right? But for the first row, you see that e to the t times cosine bt there. And for the second row also, there is e to the 3t times cosine t, right? So you need to use the product rule there, or the integration by parts. I use this formula, e to the at cosine bt is this formula. So you can use the formula directly. So what do you get there is basically equals to, so xp on the left side, there is xpt, right, equals to, let us copy that, 2 e to the negative t, and then e to the negative 3t, and then e to the negative t, e to the negative 3t, right? You do that, and then times, what is the integral of that? But after you use this formula, you will get, that's what you get after you integrate the first row and the second row. Okay, now you multiply these two matrices. If you multiply these two matrices, so how do I multiply these two matrices then? So 2 e to the negative 2 times the first row plus e to the negative 3t times the second row, that goes to the first row, right? Similarly, these times that way, okay? This is what you will get for the particular solution. So if you want to find out the complete solution, what will be the x? Equals to x1, x2, right? This is how you write x equals to x1, x2. So this will be basically, what you do is c1, x1 plus c1, x1 plus c2, x2 plus xpt, right? Xpt is that thing. Now we want to find out c1 and c2. So how do I find out c1 and c2? Is you use the initial condition, right? What is the initial condition? Use, let me do that. Use x1 0 equals to 10, and then x2 0 equals to 4. What do you get? We will get c1 is 1, c1 equals to 1, and c2 equals to, you will get negative 1. And then you plug in the c1 and c2 here, okay? Then you will get the final answer. So how would the final answer look like? The final answer look like this. The final answer will look like x vector x equals to, like this. negative e, negative 3t, plus 7 cosine t, plus 9 sine t, plus 9 sine t, plus 2, and then 2 minus twice t. This is very simplified form, okay, e to the negative t. And then negative e to the negative 3t, and then plus 2 cosine t, plus 4 sine t, and then plus 3 minus 2t e to the negative t. This is the final answer look like, okay, but I skipped some of the steps. I hope you will be able to do it. So what we do is you find out the value of C1 and C2 and then plug in C1, X1 is e to the negative t to 1, and then X2 is value of C2 is negative 1, X2 is e to the negative 3t, and then 1, 1, and then XP is basically all these things, and just combine those, right? There are not much work left there. Okay, thank you guys.